welcome to my channel. So in this slot we're going to discuss as paper 2 essay question section B and section C, which carries 20 marks. All right, 20 marks. All right, so we move on to the first question, which is known as rate of reaction temperature factor. The temperature of sodium thiosulfate react with any acid. So in this case we will take sodium thiosulfate react with hydrochloric acid or sulfuric acid. And another factor is a catalyst factor. Okay, so in this reaction, so we will remember, our student have to remember decomposition of hydrogen peroxide. When hydrogen peroxide heated, it will produce oxygen plus water molecule balance. Put 2 here, hydrogen 2, hydrogen 2, oxygen balance itself. All right, so these are the factors that we're going to discuss in this slot. So stay focused, and I will discuss a short essay. Before I move on to the question, ionic equation for the reaction between hydrochloric acid and calcium carbonate. So this reaction equation is wrong. Please check here. So I'll try to do how to do the carbonate ion. So carbonate ion all is insoluble salt when joined with any metal ion except, so we have except potassium carbonate and also sodium carbonate. Only these two salt is soluble salt. That means calcium carbonate, magnesium carbonate, copper 2 carbonate, all will form insoluble salt. So how to do ionic equation? When hydrochloric acid react with calcium carbonate, we will get carbon dioxide and water. So how to get the salt? Take the calcium ion, take the chloride ion, combine them together, so CaCl, take the charge 2, put here. All right, so this is the equation. Next step, we need to balance the equation. How to balance the equation? We check chloride 2, so put 2, the rest is balanced. And we check how to do ionic equation, so we have to remove the spectator ion, and always remember acid, it will ionize, produce ion. And here this salt or calcium carbonate is insoluble, therefore it won't break, so it exists in the form of compound. All right, so and remember this calcium chloride is soluble salt, so it will form ion. And all these is known as exist as molecules. List out all the particles that present in this reaction. So hydrogen chloride or hydrochloric acid exists as hydrogen ion and chloride ion, so we take out the ion. And here it's form compound, so take the compound. All right, so here ion, so we have calcium ion and chloride ion. Here molecule, so carbon dioxide and water molecule. So we need to remove the spectator ion. The spectator ion like chloride ion, nitrate ion, sulfate ion, please remove from this one. We need only carbon dioxide and water. So carbon is here, so I need this compound. Or hydrogen is here, so I need the hydrogen ion. So we don't need the chloride ion. So chloride ion will act as spectator ion. So how to do ionic equation? So we take the hydrogen ion, we put here, plus we take the calcium carbonate, we put here. All right, arrow, so we need calcium ion, so we put calcium ion. We need carbon dioxide and water. Balance the hydrogen 2, so I put hydrogen 2. So this is the ionic equation. Please do more revision. All right, so please do correction in the module. All right, so we move on to the next part. All right, under rate of reaction, the small question. First question, explain why the small pieces of meat cook faster than bigger size of meat. Okay, so because smaller pieces of meat has larger total surface area. Please remember it has TSA, larger total surface area. When the size of reactant is smaller, the larger total surface area will expose to heat ataupun hot cooking oil. Alright, so more heat energy is absorbed in shorter time in smaller pieces of meat, cook faster than bigger size of meat. Alright, or the factor that involved here, please write down size of reactant. The factor involved is size of reactants. Alright, we try to check this question. Okay, based on the diagram 9, in which situation the meat cook faster, and state the factor involved. So here I try to do 0.4, 4 marks. Alright, so P1, the meat in situation A is smaller. Here is uncut. This is uncut. Okay, it has smaller TSA. So this is smaller in size. It has larger TSA, exposed to what? Exposed to heat energy. Therefore, meat in situation A cook faster than the meat in situation B. So we put here meat in situation A cook faster than meat in situation B. All right, so 1 mark. So point number 2, what is the factor involved? The factor involved in this reaction or in this situation, factor involved, okay, is size of reactant. If let's say 4 marks is given, so we need to explain first point, the size of meat in situation A is smaller than the size of meat in situation B. All right, point number 4, how to do, okay, so smaller pieces of meat as larger total surface. Okay, total surface area exposed to what? Please check here. They put here heat, so exposed to, okay, heat energy. Compare to bigger pieces of meat. So fourth point. Then point number 5, we go for point number 5, thus smaller pieces of meat absorb more heat energy and cook faster, okay, or in shorter time, cook faster than bigger bigger pieces of meat. So these are the answer that students should write. All right, so we move on to the next question, next point. All right, please check here. Next one, explain why the food in pressure cooker cook faster. Because the water vapor is compressed in pressure cooker, the compression increase the boiling point of the water more than 100 degrees Celsius. The food particle gain more kinetic energy, hence the food is cooked more quickly. All right, please check the question number 11. Explain why the small pieces of charcoal burn faster than bigger pieces of charcoal. Okay, smaller, so size of reactant, same. So here will be size of reactant. The smaller pieces of charcoal, okay, are easy to ignite because it has larger total surface area exposed to oxygen. Therefore, smaller pieces of charcoal can burn quickly and release more heat compared to bigger sizes of charcoal. Okay, food can cook faster because more heat energy is absorbed per second. All right, very important, and this one very important. This now we move on to the question number 12. Explain why the food stored in refrigerator is last longer. The rate of decomposition and the rate of decaying of food is caused by bacterial action from surrounding. Bacterial action is optimum at room temperature and the food turns bad quickly at room temperature. Please check. Okay, the temperature inside the refrigerator is lower, okay, than in kitchen cabinet. Okay, at lower temperature bacteria is not active, thus the growth of bacteria slower in cold temperature and bacteria produce low toxic. The rate of decomposition of food become lower, hence the rate of food to turn turn bad is lower. All right, we move on to the next question. Look at this question. Oyan celebrate Chinese New Year by serving his family members with steamboat. He bought a lot of seafood, okay, and kept in the frozen compartment of the refrigerator. Based on the above statement, explain why the seafood can kept longer in the refrigerator. So we have point one, the rate of decomposition, and the rate of decaying of seafood. Seafood is caused by the bacterial action from where? From the surroundings. All right, so point number two, the bacterial action is optimum at room temperature and the food, or we put seafood turns bad quickly at room temperature. Then point number 3, the temperature inside the refrigerator. The refrigerator is low, and the bacteria is not active, okay, at low temperature. All right, so we go for point number 4, low temperature. All right, point number 4, the growth of bacteria at low temperature. Temperature is slower, thus bacteria produce low toxic. And point number 5, the rate of decomposition. The rate of decomposition and the rate of decay of seafood to turn bad, okay, become slower. Thus we can keep longer the seafood in the refrigerator. So please check point number 1, the rate of decomposition and the rate of decaying of seafood is caused by the bacterial action from surrounding. The bacterial action is optimum at room temperature and seafood turns bad quickly at room temperature. The temperature inside the refrigerator is low, the bacteria is not active at lower temperature, the growth of bacteria at low temperature is lower, thus bacteria produce low toxic. All right, thus the rate of decomposition and the rate of decay of seafood to turn bad becomes slower. So these are the points that students have to write. We move on to the next question. Please check this question. Okay, based on the diagram 9, which temperature option can clean the cloth faster? So we take hot water. Why? Because hot water, the temperature is higher. When temperature is higher, the kinetic energy between water molecule and detergent become higher. All right, thus we can use to clean the clean the clothes easily or faster. All right, so why? Because the first point number 1, water option can clean. Which water option? So hot water option can clean clothes faster than cold water option. All right, point number 2, we need to explain the answer. Okay, hot water as high temperature. Okay, thus the kinetic energy of water molecule and detergent is higher compare in cold water. All right, cold water. Point number 3, the clothes can be clean in shorter time and in hot water. All right, so these are the points that students have to write. We move on to the third or fourth question. Look at this one. Okay, antacid contains ingredients such as aluminum hydroxide, Al bracket OH3, and also magnesium hydroxide, and basically they are known as alkaline solution. All right, alkaline solution or alkali solution. Okay, antacid produce. Okay, so alkaline acid can provide almost instant relief for indigestion. Right, that means normally we have to chew the anti-acid tablet before we are taking into the stomach, because our stomach will produce gastric juice, all right, or stomach juice, or hydrochloric acid. When we take the tablet, we must chew the tablet so that it will break into small pieces, and it has larger total surface area. So the factor involved in this question will be size of reactant. All right, so first point number one, when we chew the anti-acid tablet, it will break into small pieces. Point number 2, okay, small pieces of anti-acid tablet. Small pieces of anti-acid tablet as larger larger total surface area exposed to the neutralization between acid and the stomach acid. All right, okay, stomach acid. Point number 3. So we have point number 3, the frequency of collision between anti-acid tablet, okay, and the stomach acid increases or become higher. Point number 4, thus the indigestion can be cured faster. All right, so these are the points that students must remember. When we chew the anti-acid tablet, it will break into small pieces. Small pieces of anti-acid tablet has larger total surface area exposed to the neutralization between anti-acid and stomach acid. The frequency of collision between anti-acid tablet and the stomach acid increases or become higher. Thus, the indigestion problem can be overcome, okay, in shorter time or can be cured faster. This question in the module page number 40. All right, so please go through all these questions. All right, we move on to the how to draw energy. This is known as energy profile diagram. Okay, energy profile diagram. How to draw this energy profile diagram? How to determine the activation energy, which is known as minimal energy required by reacting particles to react in the presence of catalyst and without the presence of catalyst. Please remember, if catalyst present in a chemical reaction, the EA will be lowered. So what is mean by EA? EA, please remember, activation energy, and when catalyst is present, the activation energy will be lower. All right, so this reaction is known as decomposition of hydrogen peroxide. In this reaction, we need catalyst. The name of the catalyst is known as manganese. Please remember to put 4. Manganese 4 oxide, so MnO2. In the presence of catalyst, and student have to draw activation energy. And please remember the decomposition of hydrogen peroxide, the energy content. The energy content of reactant is higher, and the energy content of product is lower. Therefore, the heat energy is released to surrounding, and this is known as exothermic reaction. Energy content of hydrogen peroxide is higher, energy content of oxygen molecule and water molecule is lower. So we need to draw like this. After we draw, we need to write down explanation. The reaction is exothermic, okay, and the heat energy is released to surrounding during the decomposition of hydrogen peroxide molecule. Why this is exothermic? Because the energy content of reactant, which is known as hydrogen peroxide molecules, okay, is higher than the product, which is oxygen and also water molecules. Okay, water molecule. The presence of catalyst provide alternative pathway which lower activation energy. The number of colliding particle which able to overcome the lower activation energy increases. The frequency of effective collision between hydrogen peroxide molecule increase. Thus, the rate of reaction with the presence of catalyst become higher. These are the explanation that students must give. All right, we try to check why this question. Mohammed carried out an experiment to investigate the effects of manganese 4 oxide. So this will be catalyst. All right. So please remember MnO2 will be catalyst. So we have here set 1 or experiment 1, and here we have set 2, experiment 2. And this reaction without the presence of catalyst. Here we have catalyst. All right. So here we have catalyst, and this reaction is known as decomposition of hydrogen peroxide. So H2O2 will decompose to produce, take the O2, put here. All right, take all the structure, put your H2O2 and erase the O2. And how to balance this equation? Here got 2, so put 2 in front of the hydrogen peroxide molecules and balance the hydrogen. Okay, hydrogen 4, so hydrogen 2 times 2, 4. Okay, this is the equation. The name of the catalyst, please remember, manganese 4 oxide. So here catalyst is present, here catalyst is absent. All right, so we try to check the question. First question. All right, the table 5 shows the result of the experiment for the gas is collected in the syringe, and here they put time. All right, please check your time. The time is 1 minute. So 1 minute convert into the time, 1 minute convert into a second. So that will be 1 times 60. That will be 60 second. 60 seconds. So please keep this one. And the volume collected in cm power 3. So this is 30 cm power 3 and this is 50 cm power 3. All right. So they ask us to calculate the average rate of reaction in cm power 3 per second. So how to find for experiment 1? So I put here Experiment 1, the formula to calculate the average rate of reaction will be volume of oxygen gas divided with time. All right, please remember volume of oxygen gas collected for experiment 1 is 30 cm power 3 divided with the time will be 60 second. 60 second, and please find the answer. So the answer will be 0.50 cm power 3 per second. And please do for experiment 2 also. Experiment 2, the volume collected is 50 cm power 3 and the time will be 60 second. So 60 second, we need to find the answer. 50 divided with 60, so that will be 0.83 cm power 3 per second. Make sure the decimal experiment and also the second experiment. All right, so we move on to the second question, which carries 4 marks. Look at your 4 marks. Okay, draw the energy profile diagram and label activation energy EA1. EA1 for the reaction without catalyst, and the EA2 for the reaction with the presence of catalyst. EA2. All right, how to draw? So I'll draw here. So we draw energy. Okay, axis y, we put symbol energy. So axis y, axis x, no need to draw it, unitless. And always remember, decomposition of hydrogen peroxide produce oxygen plus water molecule. All right, balance, we put 2 here, 2 here. And the reactant, always remember the energy content of reactant is higher, energy content of the product is lower. Therefore this reaction is known as exothermic reaction. So energy reactant, so we try to draw the like this energy content of the reactant. So we put the reactant here, okay, 2H2O2. All right, energy content of the reactant is higher, so always follow the order like this. All right, energy content of the product will be here. Okay, so the product will be O2 plus 2H2O. All right, so then we try to draw a curve like this. All right, so here, then after that we do what? From the reactant, we bring the line, dotted line, until the end of the product, and we try to move up here. All right, so we try to draw a line, and we try to state this is our activation energy without the presence of catalyst. So we draw a line here. All right, so this is the EA without the presence of catalyst. We try to put the EA1 without the presence of catalyst. All right, if catalyst present, the activation energy will be lowered. So we try to draw another summit like this. All right, then we try to find the activation energy of reaction with the presence of catalyst. We try to bring this one until here. All right, then we try to mark a arrow to show the activation energy has been lowered when in the presence of catalyst. All right, so here we need to label EA2. EA2. All right, so then we can put keyword catalyst. So this is the answer student have to give in the exam. So please try to do more practice. And at question number 14, so this is another type of essay question. So we have a table shows the information about experiment 1, 2, and also experiment 3. So in this experiment 1, they use zinc granules, ear powder. So that means this experiment 1 and 2 related to size of reactant. So please remember size of reactant. And experiment 2 and 3. So 2 and 3. So here they use powder, the concentration is same, and here they use zinc reacted with hydrochloric acid, and they add copper. They add few drops of copper to sulfate solution, and this one will act as catalyst. So the factor involved between 2 and experiment 2 and 3 will be catalyst. All right, please remember. So in this reaction, we try to do the equation. So I take number 1, zinc react with hydrochloric acid. So I put here hydrochloric acid react with zinc. So we will get here, we take the hydrogen ion, chloride ion. Here we take zinc ion. So during chemical reaction, this and this join ZnCl, take the two, put here. When hydrogen ion single, so we put hydrogen gas. So after that, we erase all these, we balance the chloride. Chloride will be 2, so we put 2 here. So chloride balance, hydrogen 2, hydrogen 2. When there is a volume of gas release. So we try to write down the formula to calculate rate of reaction. So divide with time, and this symbol is known as per unit. So when there's a gas, we collect the volume of gas every interval of time. So we put here volume of hydrogen gas. All right, so what is mean by rate of reaction if they ask in the exam? All right, so please use the formula total change in the total volume of hydrogen gas per unit time taken. All right, so the equation is given. The factor between experiment 1 and 2 will be size of reactant, and please remember size of reactant total surface area. The reason will be total surface area. And the catalyst factor, please remember the reason for the catalyst factor will be EA, that known as activation energy. So when catalyst present, the activation energy will be lower. All right, so now we move on to the calculation. Calculate the average rate of reaction. When they put average rate of reaction, please use the formula. So we use volume of hydrogen gas, okay, divide with time. Okay, volume of hydrogen gas divide with time. For experiment 1, so we collected the volume is 40, so the volume is given 40, and the time taken is 90 seconds, so we get 0.44. Please do like this. All right. Next one, based on the collision theory, compare the rate of reaction of experiment 1 and experiment 2. So look at experiment 1 and experiment 2. So here they use zinc granule, they use zinc powder. So this experiment 2 has a higher rate of reaction. All right, so how to answer based on collision theory? The size of zinc used in experiment 2 is smaller than in experiment 1. Larger total surface area of zinc in experiment 2 exposed to chemical reaction than in experiment 1. The frequency of collision between particles, or we can put between zinc and hydrogen ion. Okay, zinc atoms and hydrogen ion in experiment 2 increases than experiment 1. The frequency of effective collision between particles in experiment 2 also increases than experiment 1. Hence, the rate of reaction of experiment 2 is higher than experiment 1. All right, now we move on to this question E. Okay, based on collision theory, compare the rate of reaction of experiment 2 and 3. So experiment 2 and 3. So here the powder and concentration same, and they add this one, copper 2 sulfate solution, and this copper 2 sulfate solution will act as catalyst. All right, so catalyst copper 2 sulfate solution present in experiment 3 while absent in experiment 2. The activation energy of in experiment 3. Okay, activation energy of reacting particle in experiment 3 is lower than in experiment 2. The frequency of effective collision in experiment 3 is higher than experiment 2. Thus, the rate of reaction of experiment 3, okay, is higher than experiment 2. If they ask to sketch the graph, the volume collected is 40, and the rate of reaction highest is experiment 3, and moderate will be experiment 2, and lowest will be experiment 1. If they ask to sketch the graph, so the axis x will be time, so we put unit second. Here we put unit volume of hydrogen gas. So the unit will be cm power 3. The volume of hydrogen gas, the unit will be cm power 3. And the volume collected is 40 cm power 3. So we put here all 40 cm power 3, 40.40. All right, so we try to draw for experiment 3. So I try to draw for experiment 3. The volume collected all same. So this is experiment 3. The rate of reaction is higher. So I put here experiment 3, and the next one will be experiment 2. So this will be experiment 2, and the lowest will be experiment 1. So I put here. All right, so this is the graph, the graph that we should sketch for this one. All right, please try to practice. All right, we move on to the next part. Look at this question. All right, so we try to do this question. All right, experiment 1. The table 9 shows the information about the reactant and the temperature used to study the factors that affecting. When they put factor, there's a more than one factor. Please remember more than one factor here. All right. Okay. Reaction between calcium carbonate and hydrochloric acid. Calcium carbonate CaCO3 react with hydrochloric acid. So we try to check the first question. Okay. What is mean by rate of reaction and name the gas X. So what is mean by rate of reaction and name the gas X. So we try to do what? We try to write down the equation. So I try to do this second question. Write down the equation for the chemical equation for the reaction between calcium carbonate and hydrochloric acid. So I write down here hydrochloric acid react with calcium carbonate. So what I will get? Calcium chloride. We will get carbon dioxide and water. So we need to take the calcium ion and chloride ion, combine them together, CaCl, take the two, put here. So this is the equation. All right, so balance the equation. So we need to balance the chloride 2. So chloride 2, hydrogen 2, hydrogen 2. The rest is balanced. So and from this reaction, we already got the gas is released. And if we see here, the gas is collected 50 cm power 3. All right, so that means how to do the meaning for the rate of reaction. Meaning for the rate of reaction. So I put your rate of reaction. Okay, divide with time. We divide with time. So here I put change in the total volume of carbon dioxide gas collected, and this symbol is known as per unit. So how to answer this question? So we put here change in the total volume of carbon dioxide gas per unit time. So we will get 1 mark. And they want the next one, what is the name of the gas X? So I put here gas X is carbon. So we write carbon dioxide gas. So we already scored 2 marks. Now we move on to the next question. Okay, calculate the volume. Maximum volume of carbon dioxide gas is given off in experiment 1. So we try to check what is the information given in the question. So here we have 30 cm power 3. This is related to volume. And here we have concentration. This is known as molarity. All right, so of hydrochloric acid. So first step, we convert into number of mole. We convert into number of moles. So I put here number of moles of hydrochloric acid. So we use formula N equals to mv over 1000. So we apply in the formula volume 30 and molarity 0.5. 0.5 times with 30 divide with 1000. We take calculator, we find the answer. We'll get answer 0.015 mole. All right, so 0.015 mole. All right, and next step, we have to find the ratio. We look at the question. They want the volume of gas. So they want the volume of carbon dioxide gas. All right, so they want this. This is 1 mole. Here is 2 mole. Okay, take this mole. All right, so 0.015 mole divide with 2. So we will get 0.0075. So what we do here, we try to do 2 times with 0.0075. We will get 0.015 mole. And here we have 1. Okay, if 1 times with 0.0075, we will get 0.0075 mole. All right, so that's how we find the ratio. Now we write in the ratio form 2 mole of hydrochloric acid produce 1 mole of carbon dioxide. 1 mole of carbon dioxide, and we take this one 0.015 mole of hydrochloric acid will produce this one 0.0075 mole of carbon dioxide. All right, and final step, we need to find volume of carbon dioxide gas. Okay, from this formula, N equals to volume divide with molar volume. We try to rearrange this formula. We need to find the volume. So N times with molar volume, which will be given in the question. So the number of mole 0.0, number of mole will be 0.0075, which is here, of carbon dioxide, times with the molar volume. The molar volume already given in the question, which is 24 RTP. So 24. So I take 0.075 times with 24, so I will get 0.18 unit will be dm power 3. So we already score 5 marks here. All right, we move on to the next question. Okay, calculate average rate of reaction in experiment 2. So we need to calculate average rate of reaction in experiment 2. The formula average rate of reaction. The formula will be volume. Okay, volume of carbon dioxide gas divide with the time. So the volume of carbon dioxide gas collected is 50, and experiment 2, the time taken is 30. So we do what? We put here 50 cm power 3, and time taken will be 30 seconds. So we try to find the answer. So we will get the answer 1.6, okay, 1.667, or we can take 2 decimal point 1.67 cm power 3 per second. All right, we move on to the next question. How to compare the rate of reaction by using collision theory for experiment 1 and experiment 2. All right, compare the rate of reaction between experiment 1 and experiment 2 and experiment 3. So we try to answer this question. Experiment 1, so we try to find the factor. Experiment 1, they use excess of calcium carbonate chip. Here also chip, the concentration same, the temperature is different. So factor that involve is temperature. All right, experiment 2. Experiment 2 will be experiment 2 and 3. So the one we do later. So now we do experiment 1 and 2. All right, so we try to put the point 1. All right, so I do question number 4. All right, so experiment. So I write down like this: experiment 1 and experiment 2. All right, so the first point, the temperature of reacting particles in experiment 2 is higher than the experiment 1. So we already identified the factors. The reason for the factor temperature, will be kinetic energy. All right. So next point, the kinetic energy of reacting particles in experiment. Please write down full word. Experiment 2 is higher than experiment 1. So 1 mark. Next point, the frequency of collision between particles, or student can name the particles. The particles will be hydrogen ion and calcium carbonate. So the particles will be hydrogen ions and calcium carbonate, or we can put between particles in experiment 2, okay, is higher than in experiment 1. All right, next one, the frequency of effective collision between particle in experiment 2 also increases than experiment 1. All right, and last point, thus the rate of reaction of experiment 2 is higher than experiment 1. So we try to answer question like this. So experiment 1 and 2, please remember the factor that involve is known as temperature. That means the kinetic energy will increases. The temperature of reacting particles in experiment 2 is higher than in experiment 1. The kinetic energy of reacting particles in experiment 2 is higher than in experiment 1. The frequency of collision between particles or between hydrogen ion and calcium carbonate in experiment 2 is higher than in experiment 1. The frequency of effective collision between particles or hydrogen ion and calcium carbonate, okay, is in experiment 2 also increases than experiment 1. Thus, the rate of reaction of experiment 2 is higher than experiment 1. We already tried to answer this question. Now we move on to the next question. Next experiment 2 and experiment 3. So we try to find the factor involved in experiment 2 and 3. So here is experiment 2 and experiment 3. So if we check, the temperature remains same, and here calcium carbonate chip, here also calcium carbonate chip. Look at the concentration, 0.5, 1.0. That means the rate of reaction of experiment 3 is higher, the time taken is shorter. So what factor involved here is concentration factor. So here the factor is concentration of hydrochloric acid. And please remember, for concentration, the reason that we should use is number of particles. particles per unit volume. Per unit volume. And student must mention the particles. If acid, the particles will be hydrogen ion. Therefore, here we put number of hydrogen ions per unit volume. So in experiment 3 is higher. So I try to answer your point number 1. Point number 1. Okay, the concentration of hydrochloric acid used in experiment 3 is higher than in experiment 1. Experiment 2. All right, next point. Point number 2. The number of hydrogen ions per unit volume in experiment 3 is higher than in experiment 2. All right, so this is a rate of reaction between experiment 2 and experiment 3. Please remember. All right, so we go for point number 3. So we have to describe about the collision theory, the frequency of collision between particles, or student can name the particles, which is hydrogen ion and calcium carbonate. Particles are in experiment 3 is higher or increases higher than in experiment 2. All right, so point number 4, we go for frequency. The frequency of effective collision between particles, or student can name the particles like this one. All right, particles in experiment 3 also increases or higher than in experiment 2. Okay, last point number 4. Thus the rate of reaction of experiment 3 is higher than experiment 2. So that's all. So we try to read again. So first point, the concentration of hydrochloric acid used in experiment 3 is higher than in experiment 2. The number of hydrogen ion per unit volume in experiment 3 is higher than in experiment 2. We must compare the frequency of collision between particles in experiment 2, or the student can name the particles. In experiment 3 is higher than in experiment 2. The frequency of effective collision between particles in experiment 3 also increases than in experiment 2. Thus, the rate of reaction between experiment 3 is higher than in experiment 2. So, I already answered one complete essay question. Paper 2, section C, experimental essay question. Look at the essay question given here. Catalyst is used to speed up the chemical reaction, speed up the production of fuel. Based on the idea, describe an experiment to show the factor that affect the rate of reaction between zinc and acid. All right, please remember, if let's say acid react with reactive metal. What are the reactive metal? Magnesium, zinc. All right, so we can get salt and hydrogen gas. This reaction, we can get salt and hydrogen gas. This reaction can be catalyzed by adding 10 drop of copper to sulfate solution. All right, so we can need to describe this reaction. All right, so this experiment, how to describe this experiment? Before we describe the experiment, we try to draw the experiment setup to get the idea. So we take hydrochloric acid added with zinc. Okay, zinc powder. All right, so in this first reaction, we do what? We add few drops of copper to sulfate solution. This copper to sulfate solution will act as catalyst, and the experiment is repeated without adding copper to sulfate solution. So we need to describe this experiment in this experimental question. All right, so how to do? They want we try to check what is the requirement of the question. They want include the name of the catalyst. So the name of the catalyst will be copper to sulfate solution. They want the chemical equation procedure. All right, so the procedure always start with materials. List down all the materials. List down all the apparatus. Okay, apparatus. Then we start with procedure. apparatus, and then we start with the procedure. All right, so we check the first answer. The name of the catalyst will be copper 2 sulfate solution, and the second thing they want is a chemical equation. So we write down the chemical equation. So I redo again the chemical equation. So here, so hydrochloric acid react with zinc or react with magnesium. So we take out the hydrogen ion and chloride ion. So here Zn2 positive. During chemical reaction, zinc join with chloride ion. So we will get zinc ZnCl. So we take the 2, put here. Okay, zinc chloride. So, and we erase this zinc ion and chloride ion when hydrogen ion single covalent. All right, so we have hydrogen gas. So balance the equation, we just balance the chloride 2. So I put chloride 2, hydrogen 2, hydrogen 2. So this is the equation I wrote here. All right, so second step, they want the procedure. So if I will always start with material. So I will try to sketch the graph. The material that we need is hydrochloric acid, zinc powder, copper 2 sulfate solution, and also water. We need water. These are the materials. So I list out all the material: hydrochloric acid, zinc powder, copper 2 sulfate solution, and water. And the apparatus is burette, basin, conical flask, measuring cylinder to measure the solution, stopper, delivery tube, electronic balance if we need to measure, or we no need the electronic, no need to measure the electronic balance also, and stopwatch, very important, retort stand with a clamp. All right, so we try to do this one. I think we no need to no need the electronic balance. All right, so we go for this one. Fill the basin. So we try to answer this question. Fill a basin with water until full. Fill a burette with water until full and invert it into the basin filled with water. Clamp the burette vertically to the retort stand. Record the initial reading of burette. Alright, so measure 50 cm power 3. In order to measure 50 cm power 3, we need measuring cylinder. Please remember, okay, of 0.5 mole DM-3 of hydrochloric acid and pour into a conical flask. Add 1 spatula of copper 2 sulfate powder, or we can add few few drops of copper 2 sulfate solution. Okay, few drops of copper 2 sulfate solution. If we add few drop of copper 2 sulfate solution here, add one more apparatus, which is dropper. All right, so dropper. All right, so next one, close the conical flask immediately. Student must put this word immediately. Okay, and we do what? Stopper fitted with the delivery tube and connected to the rubber tube into burette, and student must start the stopwatch immediately. This word is very important. All right, and swell the mixture. Swell the conical flask continuously. Observe and record the burette reading every interval of 30 seconds. Repeat step 1 until step 8 without adding copper 2 sulfate solution. So these are the answer that students should give. Please practice. Okay, if this essay, there's one more essay that I'm targeting also under rate of reaction. Okay, section C. Okay, that will be experiment, rate of reaction, temperature factor. For the temperature factor, we need to measure sodium thiosulfate react with hydrochloric acid. We observe the formation of yellow color precipitate, which make the X mark disappear from the surface, from the side. Okay, and we do the time taken, and the experiment is repeated by using different sodium thiosulfate solution with different temperature. And please remember sodium thiosulfate, the formula Na2S2O3 reacted with sulfuric acid. Sulfuric acid. So here we take the sodium ion, thiosulfate ion. Alright, so here we take hydrogen ion and sulfate ion. During chemical reaction, sodium ion join with sulfate ion, so we will get sodium sulfate. So we erase this. So when hydrogen ion combine with thiosulfate ion, we will get H2S2O3. This is unstable compound. It will rearrange to produce sulfur, yellow precipitate, sulfur dioxide, and water. So here we put sulfur, sulfur dioxide, and water. Please remember the observation we will get. Please remember we will get yellow color precipitate. All right, so observation, yellow color precipitate. Please check the equation balance or not. So once the sodium 2, here sodium 2, everything is balanced. All right, so we try to check the question. All right, read the question. Describe a laboratory experiment to investigate how the temperature affect the rate of reaction between sodium thiosulfate reacted with hydrochloric acid. So here they use hydrochloric acid, HCl, and they want in description include balanced chemical equation. So I will start with apparatus. The apparatus that we need is conical flask. So conical flask, thermometer, measuring cylinder to measure the liquid, beaker. again beaker to pour the sulfuric hydrochloric acid. So the hydrochloric acid from the beaker will be poured into the conical flask containing sodium thiosulfate. So the material that we need: hydrochloric acid, sodium thiosulfate of 35 degrees Celsius, 40 degrees Celsius, 45 degrees Celsius, 50 degrees Celsius, a white paper with mark X at the center. All this is material. Procedure: we measure 25 cm power 3 of 0.5 mole DM-3 of sodium thiosulfate and we pour into a conical flask. The initial temperature of the solution is recorded. The conical flask is placed on the top of white paper, okay, with mark X at the center. Okay, 5 cm power 3 of 0.1 or 0.2 mole DM-3 of hydrochloric acid is measured and poured into the conical flask. We must start the stopwatch immediately. The conical flask is swelled and the conical flask is placed seat back on the white paper. The stopwatch is stopped once the X mark disappears from the site and the time is recorded. The experiment is repeated using 25 cm power 3 of 0.5 mole DM-3 of sodium thiosulfate solution with different temperature. So the chemical equation as asked in the question, so already given. So these are the two experiments that targeted for this year SPM. Please go through, and also please check page number 44. Please do this question. I already discussed in previous video. Please check how to draw the graph, how to find the instantaneous rate of reaction, how to find the average rate of reaction, okay, and also overall rate of reaction. All right, so before I end up the session, we try to do few questions. Okay, before we wrap up this slot, we try to do few questions. Look at this question, objective question. All right, so calculate average rate of reaction for the reaction. So where the maximum volume started, the maximum volume is here. So the maximum time, so maximum time taken is 90 and the volume is 24. So the average rate of reaction for the reaction 24.00 divide with 90. So calculator answer. So that will be 0.27 cm power 3 per second. So answer will be B. All right, we move on to the next question. All right, a student carried out two experiments to investigate the decomposition of hydrogen peroxide. So here the hydrogen peroxide, 0.1 mole DM-3 of hydrogen peroxide. So here without manganese 4 oxide. Here we have catalyst manganese 4 oxide. So the rate of reaction of this one will be higher. All right, so what is the function of manganese 4 oxide? The manganese 4 oxide act as catalyst. All right, so first question: increase the kinetic energy, wrong. Increase the number of particles per unit volume, this is concentration, wrong. Provide alternative route with lower activation energy. When catalyst present, the EA will be lowered, or the activation energy will be lowered. Please remember, so the answer will be C. The larger total surface area will be size of reactant. All right, look at last question. We try to answer. Calculate what is the average rate of reaction of this reaction when the volume become constant here. So the maximum time, so we take the maximum volume collected, divide with maximum time. So the maximum volume is 33.0, divide with the time is 180. So we try to find the answer. Answer will be 0.18 cm power 3 per second, which is B. All right, so these are the questions. I hope my slot will help the students. Okay, please don't give up, try to give the best. All right, so take care. We meet up in next slot. Take care. Bye bye. See y'all.